So as I said a minute ago, this is the spot rate from time zero. It's a T0. It's the spot rate between time little t and capital T observed from time T0, from an earlier time, and it would be in state J. Now we can price bonds in any one of our states. In other words, what these interest rates give us is the price of a zero in that state. So for example, if I go back to my lattice, I can price a 1-year zero here. In state 0, the price of a 1-year zero uses this interest rate, because a 1-year zero goes to time 3, and I go from time 3 to time 2. There's another time 2 zero coupon bond which exists here, namely where I use RDU as the discount rate. So you can see that I have for the 1-year zero coupon bonds starting at time 2, in this lattice I have 4 of them associated with the 4 states. And that's the meaning of this notation. It says that for every one of my period interest rates, I can calculate the price of a 1-period zero coupon bond using it. Now, this is the formula where you have to be a little bit careful. It's common in binomial lattices that the R is an annual rate. When H is 1, this formula is exactly correct. However, if you have a binomial lattice where H is not equal to 1 and the R's that you're generating are annual, you have to remember to stick in a multiplier of H. So you would take H times that rate R to discount for a period of length H. This is more common than generating period interest rates. As you know, the convention for interest rates is that they're annualized. And so it's more common to generate annualized interest rates and then to use the period adjustment in the formula. So let's price some zero coupon bonds as of time 0. We know how to price them in the future. How do we price zeros at time 0 using the risk-neutral probability? Well, the price at time 0 of a 1-year zero coupon bond just uses that first interest rate R. So in the notation of that lattice, this was R of 0, 0. It's the initial 1-year rate at time 0. How about the 2-year zero? Well, the 2-year zero, I have to discount interest, my 1-year dollar over, I have to discount my dollar value over 2 periods. But in the second period, I have 2 interest rates. And what I do is I use a risk-neutral expected value of the prices. What I'm saying is this goes from time, this discounts between time 1 and time 2. Each one of RD and RU go between time 1 and time 2, and I'm doing a risk-neutral expected value of the prices of those 2 zeros, a P with the up rate and a 1 minus P with the down rate. That gets me to time 1, and then I use this interest rate to bring me back to time 0. So because I have 2 interest rates between time 1 and 2, I have to do an expected value, and then I bring it back using the single interest rate. And notice that I can write this expected formula in terms of the zeros at time 1, the zero prices, or in terms of the interest rates at time 1. Notice in this formula, you see H. So this is a good example of where in the actual lattice, we wouldn't need an H because H is 1. But these are the general formulas where I've explicitly inserted the H under the assumption that the lattice is generating annualized interest rates. So we can price a 2-year zero either with zeros or with interest rates. And notice that even this, of course, is the price of a zero. It's the price at time zero of a 1-year zero. So with those 3 zero prices, I can price a 2-year zero coupon bond.